Good evening, everyone. Good evening. Good evening. Let's join all the people. Good evening, everyone. Good evening. Is audio video okay? Let's check. Is audio video okay? Please verify. Yeah, good evening, everyone. Good evening. Is audio video okay? Yeah, fine. Yeah, to get the updates of every class and all. So I request everyone, right? Yeah, you can like the class and you can subscribe so that every notification will comes to you. Every class notification will comes to you. So in the gate, whatever is useful information is there, right? So for placements, whatever useful information is there, everything related to CSE and DA, right? So that will be there in our channel. So yeah, you can like and you can subscribe. Yeah, I think we can start. Let's join all the people. We'll wait, I think, a few more minutes. We will wait a few more minutes. So this is going to be foundation course. Let me write. It's a foundation course or regular course. And gate CSE, gate DA. Gate CSE, gate DA. It's a combined one. Combined. Yeah, we are going to start algorithm subject. So let me start algorithms. Let me start algorithm subject. Yeah, we'll start with algorithm subject. Yeah, we can go ahead. We can start algorithm subject. But before going to algorithm, just I want to say clearly how many subjects are there, what are the weightage, right? All the things I will say to you. Before going to the algorithm subject, I will say clearly what are the weightage of every subject, how many subjects are there, when you have to complete syllabus, everything I will let you know. Everything I will let you know. So I hope all the people came. I hope all the people came. So we can start one by one. So all the people who are listening this class. So someone is saying, is it for GATE 2026? Is it for GATE 2026? Yeah, of course. This is for 2026, 2027, 2028. This is for all the people. Yeah, thanks for asking. So everyone whoever watching this, right? Please let me know. Please let me know in which year BTech you are studying. Everyone, please comment in the comment section, so that accordingly I will plan the class. Accordingly, I will plan the class. Everyone whoever there in this classroom, please comment which year of BTech you are studying. Everyone comment so that I can plan accordingly. I can plan the class accordingly. Go ahead, everyone. Which year of BTech you are studying? Everyone type. Otherwise, I don't know what to teach. How to teach, I don't know. I don't know how to teach. Everyone, please comment in the comment section. Everyone, accordingly I will plan. Accordingly I will plan. Accordingly I will plan. If at all majority is second year, accordingly I will do. If majority is third year, I will do accordingly third year. If majority is fourth year, I will do accordingly fourth year. So majority I will follow. I will get some idea how to do this. Yeah, Jonathan saying working professional. Okay, fine. We take second year. So everyone type. Don't sit idle. Don't sit idle. Don't sit idle. Everyone. In the middle of the class, I cannot ask. Now only I can ask. Middle of the class, I cannot ask. Now only I can ask. Second year, third year people. So most of the people are second year, third year people. So I think we can start. We can start now, right? We can start now. So now, before going to start this, I will just give some idea. Just I will give the syllabus. Right? So accordingly, we will start. Just I will give the syllabus idea. We can start the actual story, right? So see everyone listen. So in my opinion, today's class is starting now. In my opinion, today's class is starting now. Can you comment everyone? Can you everyone can you say one time good evening? Say everyone one time good evening. We are starting the class. Can you say one time good evening? Today's date is 6/10/25. Today's date is 6/10/25. Everyone say one time good evening. We are starting. Today's class is starting now. Date is 6/10/25. Yeah, I think everything perfect. We can go ahead. So let's see this. Date is 6/10/25. So good evening, everyone. Today's date is 6/10/25. So I'm starting now. So gate CSE or gate DA, almost same except a few subjects, almost same. So let me write it. Careful, everyone. First few minutes, listen. It is the gate CSE people. It's a gate DA people. Listen few minutes, right? Afterwards, we'll go to the actual subject. It is a gate DA people. So see the weightage. Algorithm, data structure, programming, the C programming. So this is one group. Algorithm, data structure, C programming. This is one group. Same thing here. Algorithm, data structure, Python programming. This is one group. Right? It will give approximately, in my opinion, it will give in gate examination, in my opinion, approximately by seeing the right few years, right, last 10 years paper by observing, I can say 25 marks you will get. You will get 25 marks. So here you may get approximately here you may get 30 marks because of less subjects. Gate DA, algorithm, data structures, right, Python programming, 30 marks you may get. Here you may get 25 marks you may get. Right? First, your target should be this first. Gate CS people, first target is these 3 subjects complete because it will be useful for placements also. Gate CSE people, please target these 3. Gate DA people, please target these 3 first. because it will be useful to placements also. It will be useful to placements also. I am saying again and again. It is the first target. When you are doing the gate preparation, the first target is this only. Algorithm, data structure, C programming. CS people, DA people, algorithm, data structure, Python programming. Next CS people should target this. Next CS people should target this one. See everyone? I think computer network, operating system, DBMS, I think I can say aptitude. So most probably everyone is 8 marks. CN is 8 marks, operating system 8 marks, DBMS 8 marks, aptitude is 15 marks. 15 plus 8 3 is 24. This is a one more group. This is the one more group. 8 plus 8 plus 8 24 plus 15, 24 plus 15, 34, I think 40 marks, approximately 40 marks. And one more. If you can prepare these three, if you can prepare these four, totally 3 plus 4, totally 7 subjects will give 65 marks. And one more thing is, this is required for placements. This is required for placements also. If you can do until here, placements also okay. If you can do until here, placements also okay. Get DA people, you can see. Get DA people, DBMS. Get DA people, DBMS, aptitude, DBMS and aptitude. And one more thing is going to be AI, ML. AI, ML itself will give maybe, I think approximately, this will give around 8 marks. This will give around 15 marks. Right? These two will give, I think, approximately 10 marks because it is a 4. 35 plus 8, I think approximately this also will give 40. 40 more it will be. So remember these two are for placements. DA people placement is this only. Algorithm, data structure, Python programming, DBMS, aptitude, AI, ML. That is the placements. So totally CS people contain 13 subjects. So 7 subjects for the placements. First to try placement stuff. First to try placement one, so that you will be more comfortable in the placement also. So you no need to leave the placements. Some people are saying, can I leave the placement? No need. If you are preparing GATE, doesn't mean that you have to leave placements. It is not like that. You are preparing for GATE examination, doesn't mean that you have to leave placement. There is no relation. First to complete these 7 subjects, then afterwards you prepare the remaining subjects also. Right? GATE CS people, these 7 subjects. GATE DA people, I think these 7, 3 plus 4. 1, 2, 3, 4. Yeah, 7. Now remaining subjects. Remaining subjects, if you see, right? Discrete mathematics and basic mathematics. Discrete mathematics, basic mathematics. Combinedly, you may get around 15 to 20 marks. Combinedly. Remaining things, if you see DLD, digital. DLD is the digital one. Next one is going to be COA. Let's check here how many subjects are over. 3 plus 4, 5, 6, 7. 7 plus 2, 9. 9 plus 2 is 11. Next one is going to be, I think these two will give approximately, in my opinion, I think, yeah, combinedly, there may be chance of 15 marks. Next one, TOCCD. It will give combinedly 15 more marks. This is the GATE syllabus. Approximately I written. Sometimes may increase, sometimes may decrease, something like that. It is a 65, right? It is a 65 with the 20 plus 15, which is going to be 35, approximately 100, approx. Maybe 10 marks more, 10 marks less, whatever it is, right? Maybe here you can decrease a little bit here, right? Sometimes maybe decrease, sometimes maybe increase. I written the something like upper bound. So same thing here also, basic mathematics is there. Here also discrete mathematics also there, indirectly discrete mathematics also there. So this will goes to approximately basic mathematics internally contain probability statistics also. If you want, you can add. So I think remaining one more 30 marks. Remaining one more 30 marks. Right? So this is roughly like this, roughly. So what I mean to say is first to complete the placement part. Next complete the remaining part. Both combinedly will do justification to gate also, placements also. So this is the core area, algorithm, data structure, C programming. Algorithm, data structure, Python programming, that is the core. For computer science people or DA people, core one is this area, these three, followed by remaining. Aptitude also core. DBMS also for both. Right? OS is not there for both, only for CS. CN is not there for the DA people, only for CS. Okay, fine, perfect. I think everyone is okay. This is the marks distribution. This is the marks distribution roughly. This is the marks distribution roughly. I am writing one very important one. Everyone understand. Very important thing I want to ask. I want to write. So try to understand everyone. Try to write and try to understand everyone. Gate exam is. Everyone try to understand. Gate exam is. Gate exam is. Internally, gate exam will provide infinite opportunities. Remember, infinite jobs. Infinite jobs it will provide. Gate exam, if you prepare for gate examination, infinite jobs you can. Infinite, not one job, two jobs. If anyone is done, if anyone is grown in his life like anything, gate exam is the reason. Any engineering student grown in his life a lot, gate exam is one of the reasons for that. So in the BTech, right, in your campus, you will get some jobs. I understood. In your campus, you will get some jobs. I understood. Right? So if at all gate exam is not there, you may get few jobs. Gate exam not there. Assume gate exam not there. No gate exam. Very less jobs, very less opportunities. Less opportunities. Right? Remember this also. Gate exam not there, less opportunities. Gate exam there, infinite opportunities. You can go for PSU, you can go for software jobs, you can go for higher studies. Many ways it is useful, many ways. I think all the things which are required, I said to you. Right? All the things which are required to you, I said to you. Now let's go to actual first subject, algorithm. Start now, algorithm. First subject is algorithms. This is a very important one. Algorithm is a very important one. We are starting now. Algorithm is very yeah. So algorithm is very important. I am starting everything ready. Everything ready. Yeah. So can you comment in the comment section? All the people, please comment in the comment section because of it is a starting algorithm. I am starting. Just write in the comment section. How many people know algorithm subject already? Write in the comment section. How many people knows algorithm already? Yeah. Please write. How many people know algorithm subject already? Everyone type. Already, how many people knows algorithm subject? Sir, I studied, I didn't study. Please know your status. How many people already studied algorithm subject? Everyone. How many subjects, how many people already studied algorithm subject? I want to know. Yeah, how many people? So how many people already done? Yeah, whatever level it is, college level, whatever it is, how many people already done algorithm subject? Right, everyone type. Don't sit idle. How many people studied algorithm subject? Someone is saying that studying. Currently, this subject going on. Okay. Everyone. Naveen Bhaiya bolo. Preeti bolo. Naveen Bhaiya bolo. Tejas bolo. How many people already completed algorithm subject? How many studying algorithm subject? Can you comment in the comment section? Make it fast. Arey, type yaar. Janardhan, can't you type? Maheshwari, can't you type? Bhavya, can't you type? Arey, people not typing also. Type na. Little bit type. I'm not asking your property. I'm asking just can't you type little bit? Type. So many people saying that we are currently studying. So remember everyone. Algorithm subject which I am starting now, it doesn't matter what knowledge you have. I am starting from very basic thing onwards. I am starting. If you can complete this algorithm subject as early as possible, in the computer science you can do wonders. You can do wonders in the computer science if you do from now onwards carefully. In your BTech, whatever you are studying, study. But if you listen this also properly, you can do wonder. You can do wonder in the computer science, right? So I'm starting now. Everything ready, I'm starting. This is the starting of the today's story. Until now, I am not done anything. This is the starting algorithm subject. So you cannot say I don't know basics. You cannot say I don't know this, I don't know that. You cannot say anything. Just listen whatever I am saying, it is more than enough. Right? If you want to get this subject, right? My classes are more than enough. The first thing, you want to be perfect in algorithm subject. My classes are more than enough. Right? The first one you can trust is my classes. Happily you can follow this. The best thing is for algorithm subject, right? Best thing, happily you can follow this. EPT classes you can happily follow, right? That is the best thing. So after class over, class is going on, little doubt also there you can ask. When class is going on, little doubt also there, you can ask in the class itself. Suppose class over, still you have doubt. Then you can ask in the group also. We have one doubt solving group. In that group also you can ask. Doubt is there now itself, in the classroom itself. Suppose the doubt is not clarified. In the group you can ask. Right? In the worst case, there is one book also I will give. Right? I have one book. One book also I will give. One PDF I will give to you. That is a Coreman book. Introduction to Algorithm by Coreman. Small doubts are there. You can clarify from this. Unknowingly some doubt is there. Unknowingly some small doubt came. You can ask me. You can ask in the group. Right? One of your. Yeah. So yeah, fine. So one book is there for algorithm. That is a Coreman book. Introduction to Algorithm by Coreman. There are so many others are there. It's one of the other name, Coreman, Rivest and Coreman. Right? So these are the three things. So you can happily follow my classes. Right? Everything if you get well and good. One or two doubts are there, you can ask in the class. Suppose still doubt is there, you can ask in the group. Worst case, only that topic you can refer from Coreman. Right? This subject, most probably for every subject, I will say how to follow also. Every subject, I will say how to follow also. This is the first thing. Algorithm subject, if you want to study properly, follow classes. Little doubt there, ask in the group. Still doubt there, maybe in the Coreman, only that topic. Just read little bit, that is more than enough. Right? So let us into 1, 2, 3, you done. Still you have doubt. I think, right? Last one. Maybe you can Google it out. Just to Google it. Little bit doubt is there. Suppose one of the thing, little bit doubt. You can Google it out. Maybe in the YouTube, you will get some videos. In the Google, you can type some, right? You can find out some articles. This is the last step. right? This is the procedure what you have to follow. Directly don't follow Google. Directly don't follow Coreman. Directly don't ask in the group also. First class, next group, next Coreman, next Google. If you do in this order, everything is all right. Just follow in this order. Then everything is all right. Follow this only. Don't do random stuff. Google, I will try. In the Google, people will talk whatever they want. So Coreman, I will study directly. If you study, you may not get it. Right? So the best thing is follow like this. Follow like this. Suppose, sir, I done these 4, still I am not getting algorithm. Sir, I done this first step, I done second step, I done third step, I done fourth step, still I am not getting. Then what you do is go to hell. Then go to hell. Sir, I done all, but still I am not getting algorithm. Just go to hell then. Right? So you first listen classes properly. Still doubt their group, still doubt their Coreman. Lastly, Google. You done these many things, still you are not getting them. Go to hell. What can I do? Maybe you are not believing yourself. You are not concentrating. You are not believing yourself. You are not concentrating. Then there is no other way. There is no other way. Just go to hell. Right? So be careful. This is the procedure which you have to follow. Now, I'm starting everything ready. Everything ready. Because of it's the starting class, I have to say all the precautions. I cannot go blindly. I cannot go to blindly subject. I have to take some precautions. I'm taking now. Algorithm subject starting. Algorithm subject I'm starting. So see here, algorithm. Everyone can follow. If anyone know algorithm definition, please let me know. This is the starting step. Algorithm starting step this only. If anyone know algorithm definition, please let me know. Algorithm definition. If anyone knows, please let me know. Many definitions are there. See, I am starting from definition. I'm starting from definition. So remember everyone. Remember everyone. If you don't get right, listen. If you don't know algorithm, you don't get job. Algorithm you don't know, you don't get job. Remember, algorithm you don't know means you don't get the job. Algorithm you are so great, very good job you will get. Algorithm you are so great, you will get a very great job. Algorithm you are okay, you will get okay job. Algorithm you don't know, you mostly don't get the job. Your job, your salary based on algorithm. Your salary based on DSA. Your salary completely based on DSA. You are so good in DSA. You are going to get very good job. You are okay, you will get the okay job. So DSA is a must and should, right, to get the very good job. So this is the starting point, right? This is the starting point I'm writing now. What is algorithm definition? Many people knows many definition. I am giving one definition. Algorithm definition. It is a many definitions are there. One definition I'm writing. It is a combination of. It is a combination of. It is a combination of sequence of finite steps to solve a problem. Finite steps to solve a problem. This is the definition. Many definitions are there. It's one of the definition. It's a combination of sequence of finite steps to solve a problem. It is algorithm definition. It is a combination of sequence of finite steps to solve a problem. It is the starting of algo. It is the starting of algo. Call all your classmates. Call all your classmates. It is the starting point. Until now, whatever happened, really not required. From now onwards, be careful. Until now, whatever happened, really not required. Right? So, is there any? Are you able to hear any music? Are you able to hear any music? Let me know. Are you able to hear any music? From outside, some music is coming. Are you able to hear any music? Yeah, so I think so. This is the starting of the algorithm subject, as I mentioned to you. It is the starting. It is the starting of the algorithm subject. Just I written the definition. It's a combination of sequence of finite step to solve a problem. It's a combination of sequence of finite. Many definitions are there. It's one of the definitions. It's a combination of sequence of finite steps to solve a problem. Right? Fine. So if anyone is not getting, take one example. Take the example. Take one example. Take one example. Example, I'm writing. So many examples are there. I can give one example. Let me write now. Addition of two numbers. Addition of two numbers. Be careful. Addition of two numbers. First step. Right? Algorithm definition I written. I am giving one example. Addition of two numbers. Can you see the first step? Take two numbers. First step is take two numbers. Let us assume that those are A and B. Take two numbers. Those are A and B. Assume that. First step of this, right? What is the algorithm definition I written? I'm explaining the algorithm definition. I'm writing one example. Take two numbers A and B. Okay. Second step. Second step. Add A and B, store in C. Add A and B. Add A and B and store in C. And store in C. Third point. Please learn this subject properly. That is the reason I started from definition onwards. Take two numbers A and B. Take two numbers A and B. I am writing directly here. Take two numbers A and B. Add A and B, store in C. Lastly, print C or return C. Print C or return C. It's up to you. If you want to print it. If you want to return somewhere, you can return. Print C or return C. Print element C or print number C. Whatever it is. Print number C. Print integer C. Or print C. Some number. End of this. Remember one programming language to another programming language. Only syntax will differ. One programming language to another programming language, only syntax will differ. Only syntax. In Python language, no brackets are there. In C language, brackets are there. In Python language, no brackets. In C language, brackets are there. Other than that, no difference. But remember, algorithm and data structure, not at all related to programming language. They are belongs to logics. Algorithm, data structure belongs to logics. Right? So no need to bother anything about syntax. So addition of two numbers. Addition of two numbers. Take two numbers A and B. Add A and B, store in C. Print C. This is the algorithm. If now I written the definition also open. I given the example also. Let's check one by one. Let's check one by one. Everyone see. Everyone see. It is a combination of. Remember, algorithm means it is a combination of. It is a combination of. Means all are compulsory. That is the meaning. It is a combination of. Means all are compulsory. Sequence of finite steps. If you want, you can verify. See, it is a combination of sequence of finite steps. Finite. The number of steps are 3 only. When you say algorithm, right, whatever you written, all are necessary. If all are not necessary, why you written? Assume all are not necessary, then why you written? It is a combination of, means all compulsory. And finite steps also. Number of steps should be finite. And one more, most probably sequence also important. See, after 1 only 2 will come. Can I swap 1, 2? No. Can I swap 2, 3? No. Can I swap 1, 3? No. Mostly sequence also important. But the most important thing is it should solve your problem. At the end of the day, it should solve your problem. What is the problem? Adding two numbers is problem. That problem should solve. You done something, finally problem is not solving, there is no use. So this is the definition. And everyone, there are many definitions. Book to book definition will differ. One book to another book, there is some small difference in the definition. But indirectly, directly, all are saying same story. It is a combination of sequence of finite steps to solve a problem. Finally, your problem should solve. Next one, sir, how many steps are there? 3 steps. So finite steps. So remember, every algorithm should contain finite steps. If algorithm itself contains infinite steps, time complexity becomes infinite. If algorithm itself contains infinite steps, step means one line. One line is nothing but one step. If algorithm contain infinite steps, so time complexity become infinite. That means when I run the algorithm, this algorithm taking my lifetime. So I run the algorithm, output is not coming. Waiting. So algorithm not coming because number of statement in the algorithm is infinite. It will take infinite time. So remember, algorithm should contain finite steps. In algorithm, all statements are necessary. If you think that second statement is not necessary, why you written second statement? If at all finally no output is coming, then why you written this algorithm? Then what is the purpose of algorithm? Remember, algorithm means it should solve a problem. Algorithm means it should contain finite steps. Algorithm means all statements important. Algorithm means mostly sequence also important. So please try to concentrate. Definition I said, one example I given. Small doubt also there till now, you can comment in the comment section. Small doubt also there. Small doubt also there. In the comment section, you can comment. Small, right? Small doubt also there. Until now, any doubt there, please comment in the comment section. Someone is saying that it is a step-by-step procedure to solve a problem. Exactly. Shravani, whatever you said, that is correct. Shravani, whatever you said, it is correct. It is a step-by-step procedure to solve a problem. Step-by-step instructions. Exactly. Everyone is correct. It is a step-by-step process in finite order. Exactly. Way of solving problem. Exactly. All are correct. All, whatever you are writing, all are correct. Pankaj, right? Just if you read the same notes one time, whatever I know, you will also get. So everything, everyone whoever said, your definitions also correct, my definition also correct. Everything perfect. Remember, all compulsory. If you think second line not required, then why you return? If you think third line not required, then why you return? When you say it is algorithm, all are compulsory. All statement compulsory. And number of statements are finite. Finally, it should solve the problem. And mostly sequence also important. So definition, one example I given. I hope everyone is comfortable till now. I hope everyone is comfortable till now. Let's go to next story. Write down. So algorithm definition is over. Next one. Properties of algorithm. Can you write this? Properties of algorithm. Properties of algorithm. When you say algorithm definition over, but sir, when you say I written algorithm, what properties that algorithm should satisfy? Properties of algorithm. Properties of algorithm. What properties algorithm should satisfy? If you say I written the algorithm, what properties it should satisfy? Properties of algorithm, right? So the first property, when someone will say that I written the algorithm, the first property, what that algorithm should satisfy. Let us assume that by seeing the definition, right? By seeing the algorithm definition, you written something. By seeing the algorithm definition, you written something. Right? Remember everyone, by seeing the definition, you written something and you are saying that it is the algorithm. If really it is algorithm, what properties it should hold good? Remember, first point. If it is algorithm, if it is really algorithm, whatever you written is a really algorithm. The first property it should satisfy is it should produce. Remember everyone. It should produce. It should produce. Or yeah, I can write in the some other better way. I can write some other better. If it is algorithm, the first property, it should terminate after finite time. It should terminate. after finite time. That is the first step. If at all it is algorithm, the first property is it should terminate after finite time. So if it is going infinite loop, it is not an algorithm. It should terminate. When you say it is algorithm, it should terminate after finite time. That is the first property. When someone says it is algorithm, the first step is it should terminate after finite time. You may say that, sir, algorithm definition saying finite steps are there, compulsory it will terminate. You may say like that. Sir, finite steps are there, compulsory it will terminate. Need not be. Need not be. There are some algorithms where there are something where very less steps, but it is going to infinite loop. See, the programs, whatever you write normally, everything contains finite steps only, but sometimes it is going to infinite loop. So finite steps doesn't mean that finite time. Infinite steps means infinite time. Finite step doesn't mean that finite time. Remember everyone, if algorithm contain finite step, I cannot give guarantee this algorithm will stop. I cannot give guarantee. Even though some algorithms contain finite steps, it may go to infinite loop. So I will give one example also. I will give one small example. Can you see this one? Can you see this one? While one print high. If you want, you can check. This algorithm contains very less statements, but this is going to infinite loop. This algorithm contains very less steps, but it may go to infinite loop. While one condition true, print high will be printed. But one important thing is, if it is there in the loop, it is keep on continuing. While one print high, while it is keep on going infinite loop. Remember, language to language, only syntax will differ. Right? Just I am giving a rough idea. So algorithm, whenever someone say, I written the algorithm, the first step should be, it should terminate after finite time. It should terminate after finite time. That is the first step. If something is not terminating, it is not an algorithm. You written something, it is not stopping. It is not an algorithm. Remember one more thing. Program may go to infinite loop, but algorithm don't go to infinite loop. If anyone asks you from today onwards, can you say the difference between algorithm and program? Simply say one thing. Algorithm cannot go to infinite loop. Program may go to infinite loop. There may be a chance that program will go to infinite loop, but algorithm never go to infinite loop, because algorithm first property, it should terminate after finite time. Algorithm first property saying that if it is algorithm, it should terminate after finite time. Program may terminate, may not terminate, but algorithm should terminate. That is the first property. Second property. Algorithm second property. It should terminate after finite time. That is the first property. See the second property. It should produce at least one output. Not only terminating, finally it should produce some output. It should produce at least one output. It should produce at least one output. It should terminate after finite time. That is the first step. Second step, it should produce at least one output. At least one output required. Right? One output, two output, 10 outputs, at least one output. If no output is there, then why you return? It should stop. First step is, some people are asking, sir, in the definition, finite steps are there, na? Then it will stop, na? So finite step doesn't mean that it will stop. Even though here finite steps are there, still it is going infinite loop. So algorithm means, right, first property, it should terminate after finite time. Second property, it should produce at least one output. At least one output it should produce. So how many inputs are? It may take, may not take, correct? Sometimes print high. What input I have to take? Right? So no need to talk anything about the inputs. It should produce at least one output. Right? Next one, 3. It is deterministic. Algorithm is deterministic. It is deterministic. Algorithm means there are some non-deterministic algorithms also, but we will talk about only deterministic algorithm. The programs what normally you write, they are deterministic algorithms. We will normally discuss about deterministic algorithm. However, there are non-deterministic algorithms also available. But whatever programs are, whatever user is writing, they are deterministic algorithm. It is deterministic. Means one algorithm contain one output. Algorithm is, it is deterministic. If I run one time, if I give X input, I run it, I got Y. If you run the same algorithm by giving X after some time, I want to get Y only. I don't want to see different output. It is deterministic. Algorithm should be deterministic. How algorithm is deterministic? Every statement is deterministic. In algorithm, whatever statements are there, every statement is deterministic. Finally, overall algorithm also become deterministic. What is the meaning of deterministic? Means no ambiguity. So in the first line, no ambiguity. In the second line, no ambiguity. Third line, no ambiguity. No ambiguity means no dilemma. Two different behaviors. That is called ambiguity. So in algorithm, every statement is deterministic. Overall algorithm becomes deterministic. In algorithm, every statement is deterministic. Overall algorithm becomes deterministic. So it is deterministic. Algorithm is deterministic. How it is possible? Every statement in the algorithm is unambiguous. Unambiguous, deterministic, both are same. In the given algorithm, every statement is unambiguous. Then algorithm is deterministic. So it is deterministic. So please be careful. Fourth one. Remember everyone. Everyone remember. This algorithm you can implement in whatever language you want. Algorithm is this, right? English language. See, this is called algorithm. Algorithm is not related to any programming language. Algorithm is nothing but pseudocode. This is called pseudocode. Algorithm normally called pseudocode. This is the pseudocode. Right? Just writing normal English line. Maybe some people will write in Hindi also. Some people will write in Telugu language also. Some people will write in the Marathi language also. So you can write whatever way you want in your own style you write. Algorithm is nothing but pseudocode. It is not C language, it is not Java language, it is not Python language. Algorithm is nothing but a pseudocode. Just normal English line. Whatever you are thinking, please write step by step. Whatever you are thinking, please write step by step. But remember, right, while writing step by step, right, it should satisfy the definition. Means every statement is important. Every statement is compulsory and finite steps are required. And it should solve the problem also. Now, whenever you say algorithm writing is over, please check properties are satisfied or not. It should terminate after finite time. It should produce at least one output. It is deterministic in the nature. Algorithm is deterministic in the nature. Means every statement in the algorithm, right, unambiguous, means no dilemma. First statement, no dilemma. Second statement, no dilemma. Third, every one, no dilemma. Total, this algorithm becomes no dilemma, means deterministic. Next one. Every statement in the algorithm is efficient. Every statement in the algorithm, right? So is there anyone who want to say some more properties? Is there anyone who want to say some more properties? I will write a few more. Can you write your opinion? Is there anyone who want to write right? Do you have any property? Are you thinking some other properties are there? Algorithm means it should terminate after finite time. Algorithm means it should produce at least one output. Algorithm means it is deterministic in the nature. Algorithm should be deterministic. Is there anything you want to write? Is there anything you want to say? Sushmita, do you want to say anything? Bhavya, do you want to say any property which you know? It is independent of programming language. Remember this algorithm, the algorithm which I shown, see, the algorithm which I shown over, addition of two number, you can write in any programming language. Addition of two number, in Python you can write. Addition of two number, in C language you can write. Addition of two numbers, in Java language you can write. You can write in any language. So remember, algorithm is independent of programming language. It 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 is a deterministic. It should produce at least one output. It should terminate after finite time. Someone is saying it should be easily understandable. Maybe, yeah, that is also. It is easily understandable. I will write if you want. I will write. It is easily understandable. Make sure everyone listen properly. If you are more good in DSA, you will get more opportunities. It is easily understandable. It is easily understandable. Anything else you want to write? It is independent of programming language. It is deterministic. It should produce at least one output. Don't sit idle. Don't sit idle. Tejas, don't sit idle. Janardhan, don't sit idle. Shravani, don't sit idle. Naveen, don't sit idle. Venkat, don't sit idle. Preeti, don't sit idle. Please say what you are thinking. So I given the definition. I given one example. I am writing properties also. So I think Shanti is saying that it is a feasible. What it means? What is the meaning of it is feasible? Let me know what is the meaning of feasible. Just can you give some light? Can you give some idea? What is the meaning of feasible? It is feasible. What is the meaning? Make it fast. Don't come only for sitting. Anyhow you are listening, why don't you keep your best efforts? Anyhow you are listening, why don't you keep your best efforts? It is easily understandable. It is independent of programming language. It is a deterministic in the nature. It should produce at least one output. Feasible. Should work. So no, I don't think so. It should be easily understandable. It should work. Yeah, see, if it is not working, right, you only say. Janardhan and Shanti, you only say. If it is not working, how output is coming? See, it should produce at least one output. It should produce at least one output. Whenever it is not working, how output is coming? Whenever it is not working, how output is coming? It is feasible. I didn't get the meaning. Otherwise, I could have written. That is the meaning of output. Whatever you are saying, Soumya, whatever you are saying, effectiveness. Yeah, effectiveness. So let me write that line. Sixth statement. Algorithm should be effective. What is the meaning? Unnecessary statements, no need to write. So let me write now. It should be effective. It should be effective. It should be effective. It is easily understandable. That's okay. It should be effective. What is the meaning of effective? I will write. See this one. X is equal to 1 into X. So there is no meaning. Anyhow, X is equal to 1 into X means X only. X is equal to 0 plus X. So there is no use. X is equal to 1 into X also X only. X is equal to 0 plus X also X only. What is the use? Then output should satisfy the constraint. True, Shanti. That is the meaning of output, right? It is not satisfying. What is the meaning of output? It should be effective. Effective means X is equal to 1 into X. So there is no meaning. These kind of things you can avoid. X is equal to 0 plus X. So there is no meaning. Right? So these kind of things you can avoid. So algorithm should be effective. Those people who are saying constraint should be satisfied. If it is not satisfying, how it is right? How it is output? Yeah, I am getting what you are saying. It should produce at least one output. When can I say something is output? Whichever is satisfying our conditions. Thank you, Shanti. Whatever you are saying, I understood. Yeah, fine. So few points I written. Let me write now. It should terminate after finite time. It should produce at least one output. It is a deterministic. It is independent of programming language. It is easily understandable. It should be effective. So no one will ask in the examination, For your happiness purpose, I said. No one will ask in the exam. No one will ask in the exam what is the definition. No one will ask in the examination what are the properties. No one will ask. For your happiness purpose, I said. Anyhow, I am teaching algorithm. Let me teach properly. Anyhow, I am teaching algorithm. Let me teach properly. That's what I am doing here. That's what I am doing here. Is it okay? Is it okay? Can we move further? Yeah. Can we move further? Can we move further? Can we move further? Can we move further? Few things I written. Yeah, your answer also may be right, but I don't want to write more. That output should be satisfied for the constraint. Yes, yes, that is my intention. All right. So okay, it's okay. No one will ask in the examination. No one will ask. Simply, what are the main properties I written? Four main properties I written. No one will ask definition. No one will ask properties. But anyhow, we are studying. Let's study properly. There may be so many properties also. Major things I written. So this is the first point is the major one. It should terminate after finite time. Second one, it should produce at least one output. Third one, it is deterministic in the nature. Means no dilemma, no ambiguity. No ambiguity. No ambiguity. No ambiguity. Right? It is independent of programming language. It is easily understandable. It should be effective. It should be effective. Right? Effective in the sense I said to you, unnecessary thing don't try. It is easily understandable. Means I think someone mentioned, I thought it's okay. Fifth one also not required, but anyhow, there is no problem. So remember, algorithm means logic. Remember, algorithm means logic. It is not a program. Algorithm means logic. Algo means logic. It is not a program. It is a logic. Right? Algorithm means logic. Remember that logic can be written in any programming language. Any language you can write. Any language you can write. Algorithm means logic. That logic can be written in any language. Any language you can write that logic. This is called algorithm. Simply normal pseudocode. Normal code, normal English line, normal Hindi line, normal Telugu line, normal Marathi, normal Punjabi, whatever language you want, you can write. Step by step procedure. Follow this definition. Right? It is a combination of sequence of finite state to solve a problem. So one example I given, some properties I written, everything is fine. Now let me write now. It's one more important story coming. Listen that one also. Listen that also. Steps needed. Steps needed to design algorithm. To design algorithm. This is the next story. Can you listen this also? Can you listen this also? It will be very useful to you. Steps needed to design algorithm. Sir, I want to design algorithm for a particular problem. How to proceed, sir? If you write blindly, properties may work, may not work. I have a problem. I want to solve the problem. I want to write algorithm. So how to write the algorithm? If you write blindly, these properties may work, may not work. But if you follow some procedure, steps needed to design algorithm. If you follow some procedure, right? So then you are going to get very nice algorithm. Steps needed to design algorithm. Steps needed to design algorithm. If you follow steps, then you will get the very good algorithm. Let's follow steps. Don't write blindly. So remember, if you prepare the gate examination blindly, You may get the rank, you may not get the rank. If you follow some procedure, you will get the rank. In the similar way, in your BTech also, if you want to get the maximum percentage, if you want to get the maximum percentage in the BTech, right? If you do blindly, you may get, you may not get. But if you follow some procedure, you will get the very good percentage. In your college campus placements also, if you do blind preparation, you may get the job, you may not get the job. But if you follow some procedure, you will get the job. So steps needed to design algorithm. So don't write algorithm blindly. Follow some steps. There is some procedure. If you follow that procedure, you are going to get a very good algorithm. You are going to get a very good algorithm. So let's start now. Let's start. What are the steps needed to design algorithm? Remember everyone, it is a problem. It is a problem. Careful, it is a problem. To solve this problem, I want to write algorithm. There is a one problem. To solve that problem, I want to write algorithm. See the first step. If you want to write algorithm for any problem, the first step is know the problem clearly. That is called problem definition. To solve any problem, if you want to write algorithm, the first step is problem definition. Know the problem clearly. Know the problem clearly. That is called problem definition. Know the problem clearly. Whenever first step is over, that means, listen, when the first step is over, that means for your problem, for this problem, if I give X as input, right, what is the output? Y. If I give A as input, what is the output? B. So for every input, you are going to get what is the actual output. That is the meaning of understanding the problem. If I give this input, I am expecting this output. If I give this input, I am expecting that output by satisfying conditions and all. So knowing problem clearly, that is called problem definition. So X input, Y output, A input, B output, C input, but I don't know output. That means problem not clear. Right? For the input C, you don't know what the output. That means problem not clear. So you should know this input, what is the output. Input to output matching should be clear. That is the meaning of understanding problem. So X is input, Y is output, A is input, B is output, C is input, output you don't know. Oh, problem not clear. So if you want to design algorithm, the first step is know the problem clearly. Don't write blindly something. Don't say that, right? Algorithm is over. So the first step of algorithm design, problem should be clear. Next one, suppose assume that C input, output I don't know. Check properly. What is the problem? Get the clarity. So after getting clarity, I got to know C input, output is D. E input, output is F. And so on. V input, W output, something like that. So no problem clearly. So for every input, I know what is the output. That means problem definition clear. This is the first step. That is the reason people used to say. Everyone listen. That is the reason people used to say, if you know the problem clearly. That is the reason people used to say, if you know the problem clearly, half of the problem is over. If you know the problem clearly, half of the problem is clear. Half of the solution you got. Right? If you know the problem clearly, half of the solution you got. So steps needed to design algorithm. First step is knowing problem clearly, problem definition. Right? Second step, problem clear, right? Problem definition is over means problem clear. Problem clear. This step is going to be very, very important. Second step is going to be very, very important. What is the second step? Let's see this one. Right? See the second step. Design algorithm. Second step is very, very important. Design algorithm. Second step is very, very important. Design algorithm. Right? Knowing problem clearly, that is okay. Second step is design algorithm. So what I mean to say is remember everyone, after knowing the problem clearly, the people who are working in algorithm subject, after knowing the problem clearly, right? So you have to design algorithm. What I mean to say is algorithm subject having already algorithm. Algorithm subject having already algorithm. To right after knowing problem clearly, right to this problem in the existing algorithm subject. So many algorithms are there. Which algorithm is more suitable? You have to select. So design algorithm is nothing but algorithm subject having so many algorithm or so many designing technique. You should find out which is more suitable to your problem. You no need to design every time from scratch. Already algorithm subject having so many algorithm. To your problem, which algorithm is more suitable, you have to map. Nowadays, that one used to call as right in the internet, right, or LinkedIn, or maybe YouTube. That one normally called as pattern matching. To your problem, which pattern? Please identify. If the interview person will ask one question, you have to check, this problem can be solved using two pointers. This problem can be solved using, right, one fast pointer, one slow pointer. Oh, this problem can be solved, using sliding window. Oh, this problem can be solved using divide and conquer. This problem can be solved using DP. This problem can be solved, right, using dynamic programming. This problem can be solved using LCS. So what I mean to say is, algorithm subject having already so many algorithms. Your problem is more suitable to which pattern, please find out. That is the second step. Design algorithm or propose a designing technique. Don't write anything from scratch. You no need to write anything from scratch. Some people, those people who don't know anything about algorithm subject, what they will do is, algorithm subject learning is nothing but for every problem I will write from scratch. Then you are not learning algorithm, right? You are doing some nonsense. You are learning some bullshit. Some people are thinking that algorithm subject studying is nothing but for everything I will write from the bottom. From the scratch I will write. From the scratch everything if you write, then what is the purpose of studying? What is the purpose of studying? You only say. Right? So if you are, right, the purpose of studying is algorithm subject having so many algorithms. To your problem in the existing algorithm, which is more suitable, please take it. That is called, right, your problem. Which pattern matching, right? Select the pattern. So, yeah, your problem can be solved using DP. Oh, your problem can be solved using greedy. Oh, your problem can be solved using two pointer. Yes. So, in the interview, someone in the interview person is asking, right? This is the problem. How you solve? This is the problem, how you solve. Then you have to think, you no need to write from scratch. You have to say something like, take some time and say, yeah, this can be solved using greedy technique. Oh, this can be solved using divide and conquer. This can be solved using DP. This can be solved using two pointer. This can be solved using subsequencer, right? This problem can be solved using matrix chain multiplication, something like that. So, second step is very crucial in algorithm design. Know the problem clearly. See, without knowing problem clearly, what algorithm I will suggest? After knowing problem clearly, in the existing algorithm, which algorithm using which pattern you can solve this problem? Please say that pattern. That is called designing algorithm, which is nothing but finding pattern. That pattern may be divide and conquer. Major things I'm writing. That pattern may be greedy technique. That pattern may be dynamic programming. That pattern may be backtracking. That pattern may be right, branch and bound. There are some different. I can write so many things. That pattern may be two pointer. That pattern may be one slow pointer, one fast pointer. That pattern may be, right? That pattern may be, I can say something like sliding window. So some different, there are so many keywords are there. 50 kind of keywords are there. Right? So when you are solving more problem, you will get to know more pattern. Approximately 50 patterns are there. So for every pattern, if you solve 3 problem, so you can easily crack the any company. You can easily solve the any company. For every pattern, do 3 problems. So 50 patterns are there. 50 into 3, if you do approximately 150 to 300 problem, any company you can crack. So second step is going to be, right, in the available pattern or in the available designing technique, Which designing technique more suitable to your problem? Please find out. Okay. After doing a lot of hard work, I got to know DP is best. Okay. So third step, I think the second step is over, means algorithm already you got. DP having some algorithm. Already you got model, right? The only thing is you don't have program. So now you got some idea. Algorithm almost you got it. So what you do is draw flowchart. Second step is over, means algorithm you got. Approximate algorithm. Mapping you done. So third step is going to be draw flowchart. Right. Draw flowchart. So third step is going to see. Second step is over, means you got algorithm. Third step is over, means draw the flowchart. Whatever algorithm you have, right? Diagram format you write. Algorithm contains, I think, pseudo code. Third one is going to be draw flowchart. Means you are writing in the diagrammatic manner. Fourth step is going to be, I think, flowchart also available. Using flowchart, right? Try to apply these all the things, right? For this input output coming or not. Do testing or verification. So after flowchart also available, means algorithm you written in the form of a diagram. It's the starting point. Afterwards, right? So maybe condition true, you will go left side, otherwise go right side. So you are writing in the diagrammatic format. Diagram format you are writing. In the diagram format. So by giving all these inputs, please verify, right? That is called testing. For every input, correct output is coming. So then there is no problem. For every input, correct output is not coming. So you have to go to, right? So you have to go to designer, you have to say, in the pattern, whatever you are taken, small conditions not satisfying, please change a little bit. Then the designer will change a little bit. Again, flowchart will be drawn. Again, testing. So this will continue until all are correct. This will be keep on continuing until all are correct. So fourth step also completed, right? So testing also successful, then everything is fine, right? So go to the fifth step. Right? Testing is over, then everything is fine. Then fifth step. Fifth step is going to be, careful, fifth step is going to be analysis. Means you have to find out what is that, how much time complexity, how much space complexity. Whenever testing is successful, means you have one algorithm. That algorithm will take how much time complexity, how much space complexity, you find out. Right? So you find out if you think that time complexity, space complexity, better. If you think that everything fine, then lastly go to the sixth one, coding, which is called implementation. If at all, if I feel that time complexity is good, space complexity also good, everything fine, then I will go for implementation. Until now, no program. This is called coding or implementation. Last step is you can go for coding. Right? See this one, whenever last step is not done, until now you only running. See, no coding. Until fifth step, no coding is there. You only running. But at the end of the day, computer should run. Na? Last step is coding. So remember, after coding is over, there also you can do testing. That is called programming language coding. Right. Sorry, that is called programming language testing. This is logic testing. The design technique, whatever you done, that is correct or not, right? This testing will take care. This testing is based on designing technique is correct or not. This, right? This particular testing, seventh one, if you want, you can add testing here also. Coding is correct or not. Testing can be done everywhere. Problem definition time also you can do testing. Right? Next one, designing algorithm also you can do testing. Right? So these are the I think I can say maximum steps. Right? So what I think company to company steps will keep on change. In some companies, same story can be done. Big companies. In the big companies, same story can be done with the help of 50 steps. In small companies, same thing can be done with only one step. Startup companies, one step only there. Directly coding. Startup companies, if you give any problem, they will do direct coding. If you give to big company, they will do 50 stages, 50 parts they will divide. So company to company, it will keep on change. But I give a rough idea. See this one. Steps needed to design algorithm. First step, know the problem clearly. So problem is clear. Then in the existing algorithm, which algorithm or which pattern more suitable to your problem, please check. In the existing algorithm, right? In the existing algorithm or existing pattern, which is more suitable to your problem, please check. Okay, you selected one of the pattern. Now, whatever pattern you selected, to that pattern, draw the flowchart. Because until now, only English statements are there. Draw the flowchart. Because of you have a flowchart by giving different inputs, you please verify. If everything fine, okay. If not fine, right? So say to the designer, some problem is there, please change it. Designer will do small change. Again, flowchart also small change. Again, testing. Continue until right every input output is coming. Then whenever everything is perfect, then check what is the time complexity, what is the space complexity. If you think time complexity, space complexity good for the designing technique which you selected, time complexity, space complexity, okay, good, then you can go for coding. Don't do coding for every logic. Don't do that. When you confirm it is a good logic, only for good logic do coding. Bad logic, don't do coding. Logic means what? Designing technique. Right? Designing technique is nothing but a logic, which is nothing but a algorithm. Second step is algorithm. Remember, in algorithm subject, we don't write anything from scratch. Algorithm subject having so many algorithms. We have to select for our problem which algorithm suitable. Oh, to my problem, greedy technique is suitable. To my problem, DP is suitable. To my problem, branch and bound is best. To my problem, backtracking is best. To your problem, which technique is more suitable, select. Until now, I have only pseudocode. Draw flowchart in the form of a diagram. Now I have a flowchart. By giving different inputs, I can check, do testing. If everything perfect, then go to the further story. If at all not perfect, go back. Ask the designer, the pattern, whatever you selected, everything is working fine. Some things are not working. He will change a little bit. Draw the flowchart, again testing. Continue until no more bug. Then whenever everything is fine, then check time complexity. The logic, whatever you selected, what is the time complexity, check. What is the space complexity, check. If you feel, if you convince time complexity, space complexity, okay, then go for coding. Suppose if you don't convince, then select one more logic. Right? Do the once again flowchart. Do once again testing. Everything okay. Once again analyze. Time complexity, space complexity. If you feel okay, then you can do coding. So these are the steps. Remember, these are not standard. Company to company will change. In TCS company, same story will be done by 50 steps. In the startup company, same story will be done one step only. In the moderate company, same story will be done in the 10 steps. Right? If you go to the Microsoft, same thing will be done maybe with 100 steps. So company to company, and right, I think I can say budget also. What is the budget of the project? If the budget of the project is more steps are there. If the budget of the project is very less steps are there. So there is no standard thing, only these many steps are there. So remember, until now I said very less story, very less. What is the definition? What, right? Next one, what is the example for the algorithm? What are the properties? Right? These are the properties. Next one, what are the steps I have to follow so that I can design algorithm? Remember everyone, if you follow these steps, whatever final output is coming, that will satisfy all properties. If you follow some procedure, whatever final output is coming, that will satisfy all the properties. See, I think after these steps are over, whatever you got, whatever program you have, you check yourself. You got to know it should terminate after finite time. It will terminate also. If not terminate in the testing area, see here you will stop. If at all not terminating, testing will stop, right? So it will terminate after finite time. At least one output should produce. It is deterministic in the nature. If at all it is not deterministic in the nature, testing you are doing again and again, outputs are keep on changing. It is a serious issue. So it is deterministic in the nature. It is independent of the programming language. It is easily understandable. It should be effective. It should be effective. I feel everyone is comfortable. Yeah. Let me know if anyone having any doubt. Any doubt do you have till now? Do you have any doubt till now? We really done very good work. We really done very good work. I am going so slowly. I am going so slowly so that everyone will get. I am going so slowly so that everyone will get. Is it okay? Do you have any doubt? Do you have any doubt? So remember, last step is coding. Remember, last step is coding. Right? Before that, analysis. Last step is coding. Coding means implementation. Whenever you got to know everything, okay. Okay, until now, human being only running. Let's run by computer. Means computer can understand computer language only. Using one of the computer language, do coding. Using one of the computer language, do coding. Some people are thinking algorithm design is nothing but everything I will write from scratch. No, no. In the existing pattern, which pattern more suitable to your problem, please select it. So selecting pattern is more important. If you select the wrong pattern, it will also give output, but it will take a lot of time. So saying something wrong and making it as right, it will take a lot of time. You said some lie. To make it lie as a correct one, you have to play so many lies, so many lies, so many lies. But one thing is true, everything possible in life. Everything possible in life. You can prove you done something wrong and you can prove that you are correct also. But you have to do so many lies. If you do correct one, to prove it you are correct, it will take very less time. If you do wrong thing, to prove you are correct, it will take a lot of time. So what I mean to say is, if at all wrong technique, right, wrong designing technique, if you select, right, it is very difficult. So most of the inputs may not satisfy. When you take the wrong thing, so most of the inputs will give wrong answers. To adjust them, it will take a lot of time. So the best thing is, best designing technique you select, more suitable. Then most of the inputs will give correct output immediately. One or two may not give. So you can adjust. One or two adjusting is easy. Then one or two only satisfying. Remaining things are not satisfying. That is going to be difficult. Right? I think you people done really good work. Now listen. Now listen, everyone. I think we really done very good work. Just I want to say one more important thing. Please listen. Please listen, everyone. Our subject name is algorithm and design. See, algorithm. See this one. Algorithm, design, and analysis. ADA. Our subject name is algorithm, design, and analysis. Design and analysis. Algorithm, design, and analysis. These are the two steps. Or AAD, algorithm, analysis, and design. Or DAA, our subject name is DAA, design and analysis of algorithm. So what I mean to say is, we are going to cover only these two steps. In algorithm subject, we are going to cover only these two steps. Our goal is analyzing algorithm, designing algorithm. We don't bother that much about coding because anyhow you learn, right? In your college, right? In 4 years, you will learn so many languages. In algorithm subject, we will concentrate only two things: how to design algorithm, how to analyze algorithm. Only those two things we will take care. In algorithm subject, we will take care two things only: how to design algorithm, how to analyze algorithm. Analyzing means time complexity finding, space complexity finding. Right? So designing means which pattern more suitable. Pattern finding. Pattern finding. In the LinkedIn, you will see one famous thing, this only. Right? Just learn, right? Just learn for every pattern few problems. For every pattern, learn few problems. So that if anyone say any problem, directly use that pattern and complete the story. You no need to write everything from scratch. You can find out, oh, this problem, this pattern is perfect. So pattern matching is called designing algorithm. Right? After designing algorithm, you can analyze that algorithm is how much time, how much space. So in this subject, we will study only two things: algorithm design and analysis. So different universities, different names. Different universities, different names. Right? Try to remember. Now this is our first chapter. Analysis is the first chapter. Can you write now? Analysis is the first chapter. First chapter of algorithm subject is analysis. Afterwards, we will see, right, design. Let me complete the analysis. Analysis means time complexity finding, space complexity finding, how. First chapter is analysis. First chapter is analysis. Remember, be careful, be careful. First chapter is analysis. Time complexity finding, space complexity finding. Right? So I will write. What is the purpose of analysis? Right? Write down now. If a problem having, this is the first chapter, be careful. If a problem having more than one algorithm, if a problem having more than one algorithm, if a problem having more than one algorithm, then best algorithm decided by if a problem having more than one algorithm, then best algorithm decided by analysis. That is the purpose of analysis. If a problem having more than one algorithm, then best algorithm decided by analysis based on two factors. Based on two factors. Based on two factors. One is time complexity. Another one is space complexity. Time complexity means while running, whenever your algorithm is running, how much CPU time? Running means CPU, right? Whenever your algorithm is running means CPU, right? How much CPU time it will take? CPU time. Time complexity means CPU time. Whenever your algorithm is running, it should there in the main memory. How much CPU, right? How much main memory space it is taking? Main memory space. How much main memory space it is taking? That is called space complexity. How much CPU time it is taking? That is called time complexity. Remember, if a problem having more than one algorithm, then best algorithm decided by analysis based on two factors: time complexity, space complexity. Whenever your algorithm is running, how much CPU time it is taking? That is called time complexity. Whenever your algorithm is running, it should there in the memory. How much main memory space it is taking? That is called space complexity. Right? Fine. Perfect. Perfect. This is also okay. Everyone comfortable till here. Everyone comfortable till here. Now let's write here. So analysis. So I think you can write now. Time complexity finding. Be careful. Topic is time complexity finding. How to find out time complexity. Be careful. So this is, I think, that is the starting point. Time complexity. So what remember Remember, 3 classes. We are going to discuss from now onwards 3 classes. Time complexity finding only. 3 classes we are going to discuss about time complexity finding only. Right? So analysis is 2 types. Analysis is based on 2 factors: time complexity, space complexity. How to find out time complexity? I am going to explain. Time complexity. Right? Time complexity. Please be careful. Please be careful, everyone. Time complexity. Right? Let me see this one. Everyone be careful. Everyone be careful. Time complexity of a program P. Right? Time complexity of a program P. Program or problem, whatever it may be. Right? Time complexity of your program P is equal to time complexity of your program P is equal to, first of all, you have to compile a program. You have to compile a program. Time complexity of your program P is equal to compile time of program P plus running time of program P. Time complexity of your program P is equal to compile time of program P, running time of program P. Running time of program P. Time complexity of your program P is equal to compile time of your program P plus running time of your program P. Remember everyone, compile time of your program P. Compile time is based on compiler. Time complexity of your program P, first you have to compile also, next you have to run also. Right? Compile time of your program P is based on compiler. Compile time is based on compiler. Running time is based on processor. Be careful. Compile time plus running time. Compile time is based on compiler. Running time is based on processor. So remember, compiler is a software. C compiler, it is a software. Java compiler, it is a software. That is the reason compiler you are installing. So compile time is based on compiler. Compiler is a software. Software means, right, software written using some programming language. Right? But a processor is a hardware. Processor is a hardware. So what I mean to say is, compiler is a software, means in some programming language you written. Processor is a hardware, right? So remember, in which programming language you written. When you say software, programming language, in which software, in which language you written. Suppose assume that software is written some old language. Compile time is more. If that software is written some updated language, new language, compile time may be fast. So what I mean to say is, compile time is based on compiler. Compiler is a software, right? So compile time is based on programming language. It is based on programming language. So slow language, compile time is more. Compile time is based on programming language. It is a software. Software is based on programming language. Right? Next one, running time is based on the processor, which is the hardware. Right? So remember which type of hardware you are using. Yeah, is it fine now? Is it fine? Yeah, sometimes it will happen. Sometimes it will happen. Is it okay now? Is it okay? Analysis purpose is finding time complexity, space complexity. Yeah, is it fine now? Now is it okay? Now is it okay? Now it's fine. Can we go ahead? Can we go ahead? Yeah, perfect, perfect. It will happen sometime. That is the meaning of live. Live may be some small interruptions may be there, right? Sometimes no interruptions, sometimes more interruptions, sometimes less interruptions, something like that, right? Let's go ahead. Let's go ahead. Let's go ahead. So time complexity is based on compile time plus running time. Compile time is based on compiler, which is a software. When you say software means programming language. In which programming language you are writing compiler. Compiler is written using some modern language. It may take less time. Compiler is written using some old languages. It may take more time. Running time is based on the processor, which is the hardware. Which type of hardware? Right? If you are using the faster processor, it will take less time. So type of hardware matters. Type of hardware matters. Type of hardware matters. Type of programming language and the type of hardware matters. Remember, time complexity completely based on programming language of a compiler, type of hardware, type of processor. Right? I'm writing those two also. Right? Compile time is based on programming language of compiler. Right? Compilation purpose, which programming language you are using? Programming language of compiler. And one more thing is type of hardware, type of processor. These two things will decide the time complexity. If these two people are better people, less time. If these two people are worst people, more time. Time complexity based on these two people. So remember everyone, if anyone having small doubt also, we are entered into the analysis chapter. right? So if your problem having more than one algorithm, then best algorithm decided by analysis, which contain two factors, right? This analysis will will decide which one is the best algorithm by time complexity or space complexity. These two will decide which is the best algorithm. Let's talk about time complexity. Time complexity of a program is equal to compile time plus running time. Compile time is based on, right, what is the programming language of compiler. Running time is based on what is the type of processor. If these two things are better people, right, it will take less time. These two people are worst people, it will take more time. So be careful. Now remember. It's a very, very important one. It's a very, very important one. Now remember. Now remember everyone. Right? Right now, analysis will be two types. Analysis purpose is finding time complexity, space complexity, okay. But analysis will be two types. Analysis will be two types. Post theory analysis. Post theory analysis. Second one is the priori analysis. Remember, A is silent here. Post theory analysis and priori analysis. Right? Post theory analysis and priori analysis. The analysis will be two types. Post theory and priori analysis. Right? Be careful this also. Small theory is left out. Afterwards, so many numerical problems. So many numerical problems are there. Priori analysis will be two types. Post theory analysis and priori analysis. Right? Now listen. If someone asks what the time complexity of your program, if someone asks what the time complexity of your program, you know time complexity based on two factors. Programming language of compiler, type of hardware. Right? So if someone asks what is the time complexity of your program, so if you ask what is the language of the compiler, what is the type of hardware, right? So it is dependent on language of compiler and type of hardware, type of processor. Programming language of compiler, type of hardware. It is dependent. What is the meaning? If someone asks what is the time complexity, you will ask them immediately what is the programming language of compiler, what is the type of hardware. You will ask these two things. These two things are best, you will say less time. These two things are worst, you will say more time. So according to post theory analysis, A silent. According to post theory analysis, right, it is dependent on programming language of compiler, type of hardware. Without these two things, I cannot say time complexity. If someone asks you what is the time complexity of this program, you will simply ask what is the language of compiler, what is the type of hardware. So it is dependent on these two. These two things are not there, I cannot give the answer. These two things are not there, I cannot give answer. These two things are there, then only I can give answer. But see the second analysis. It is independent. It is independent of. It is independent of programming language of compiler, type of hardware. These two things you know, then only I can give answer. That is called post theory analysis. These two things doesn't matter, whatever these two, right? It is going to be priori analysis. Second one, see the second point of both. Over almost all theory over. I know very well theory is a little boring, right? Within few minutes problems will start. So starting at least I have to say a little bit of theory. I cannot go directly problems. Post theory analysis. It is dependent on programming language of compiler and type of hardware. Priori analysis. It is independent of programming language of compiler, type of hardware. That is the first step. So because of see everyone now. These are the real things. Real things you are taking into consideration. But these are the real things he is not taking care into consideration. Real things, second one is not taking care. But real things, the first one is taking care. Because of real things is taking care, you will get the exact answer. It will give exact answer. It will give exact answer. But because of is not taking real things into consideration, it will give approximate answer. It will give approximate answer. Real things, if you don't consider, definitely will get approximate answer. Right? So first model will give exact answer. Second model will give approximate answer. Okay, that's fine. That's fine. The problem with the first model is it is giving exact answer. Okay. The problem is I have a one program. What is the time complexity I'm asking? But it is dependent on the real things. Programming language of compiler, type of hardware. Suppose assume that I given one program. I ask what is the time complexity. One person will say time complexity is 5 minutes. One person will say time complexity 1 hour. Because the person who is saying 1 hour is having slow processor. The person who is saying 5 minutes is having faster processor. The person who is saying 1 second is having the supercomputer. So what I mean to say is in the posterior analysis, answer is based on programming language of compiler, type of hardware. These two best answers will come. These two are worst answers will come. So because of that reason, with the dependent analysis, it will give exact answer. The problem is computer to computer, person to person, different answers will come. So it will give different answers. Because of real things are changing, automatically answer will change. It will give different answers. In supercomputer, very less value will come. Right? Because we are talking about time complexity, remember. We are talking about time complexity. In supercomputer, less time will come. In the slow processor, more time will come. It will give different answers, means different times, different answers from system to system, from computer to computer. When you say dependent, right? So dependent thing is changing, automatic answer will change. It will give different answer from computer to computer. Slow computer, it will take more time. Right? So faster computer, it will take less time. Because of is independent anyhow. Slow computer also same answer, faster computer also same answer. It will give same answer. It will give same answer in same time in all computers. So with this theory will be over, don't worry. So from now onwards, algorithm is so interesting. From now onwards, algorithm is so interesting. Analysis will be two types. Posterior analysis, priori analysis. The name itself saying posterior means postpone. Posterior means postpone. What is the meaning? If I ask the time complexity, instead of giving time complexity, they are asking something else. What is the language of compiler? What is the type of hardware? That is the reason it is a postponing my question. It is asking something else. But what is the meaning of priori analysis? Immediately. It is independent of programming language and programming language of compiler, type of hardware. Because of independent, right, it will give approximate answer. Real things it is not taking into consideration. It will give approximate answer. The advantage is in every system, same answer. Because it is independent. But in the first one is a dependent. Because of dependent things you are taking into consideration, it will give you exact answer. But the problem is person to person, computer to computer, different answers are coming. So please careful, all the theory we done. Very systematically, I said, very systematically, because, right, I have to take care about every point. I have to take care about every point. From here, you take care. Definition, I said, one example I given. Next one, based on that definition, if you write something, whatever you want, it is not an algorithm. Every algorithm should follow some rules and regulations. They are called properties of algorithm. Many properties are there, but it is a wastage of time. Some unnecessary thing I didn't return. Major things I return. Right? It should terminate after finite time. It should produce at least one output. It is a deterministic in the nature. It is independent of programming language. It is easily understandable. It should be effective. right? Like that, so many are there. Some more people said some more thing. I don't want to write unnecessarily more. I written few things, right? Next one, algorithm means it should satisfy some properties. Some people are asking, sir, how can I generate algorithm which will satisfy all these things, right? That is the reason you have to follow some steps. You cannot write blindly. Steps needed to design algorithm. So when you do blindly, it may not satisfy anything. If you follow some procedure, it will satisfy, because procedure means there is some relation from step to step. So first step, right? So the best way to design any algorithm is first step, know problem clearly. For every input, what is the output? Please get to know. Suppose for some inputs you don't know what is the output. Means problem not clear. Do you believe or not? Some big companies will spend years of time, 1 year, 2 year, 3 year, in the problem definition only. Some big companies, suppose if I have any government project, so normally it will take 10 years. If government will give project to any person, right, they may take 5 years, they may take 10 years, because they have to know the problem clearly. In the government, no one will work so fastly, right, to know the problem clearly, right? If I get any government project, if I want to work on the government project, right, if I want to finish it off, it will take a lot of time, because in the problem definition itself, I will spend a lot of time. I have to ask every inquiry, like X is given input, what is the output? Because of government people, they may not give answer immediately. They will say, let me ask my boss. Let me ask my boss. Let me go to chief minister. Let chief minister will ask prime minister. There are so many levels. So what I mean to say is a big project, right? At a problem definition itself, they will take a lot of time, because they are not clear with the problem. For every input, what is the output, they have to get to know. Suppose for some input, output we don't know, means problem not clear. If problem not clear, what answer I will give? So know the problem clearly. Problem clear, then right, algorithm subject having so many algorithms, right? Algorithm designer, the person who is an experienced person, by seeing the problem, he will say, oh, this kind of problem, go to DP. This kind of problem, go to DAC, divide and conquer. Oh, this kind of problem, go to, right, sliding window. Like that, people will give ideas. So second step is based on the problem, right? So based on the problem, the people who are experienced in algorithm, they will map the algorithm. They will map the pattern which is already available. So remember, algorithm subject is nothing but we are not doing anything from scratch. Existing thing we are utilizing efficiently. So, right, after problem definition is over, right, in the available existing designing technique, which is more suitable to your problem, please map it. So you done the mapping. You took one of the algorithm which is existing for one of the new problem, you done the mapping. So it may work, may not work. So because of you have a algorithm, right, you have some inputs also. What you do is, for that algorithm, which is a pseudo code, draw the first flow chart. On that flow chart, by applying these all inputs, check one by one. Testing is going on. For this input, this flow chart working or not. For this input, this flow chart is working or not. If everything working fine, so perfect, then go for analysis. How much time? How much time your algorithm taking? How much space your algorithm taking? Analyze. Suppose time and space also perfect. Then last step is go to coding. Suppose for some inputs it is not working. Say to the algorithm designer, whoever designed it, the pattern whatever you taken, the designing technique whichever you taken, some inputs it is not working. Can you change it? You will add one line, you will delete one line from the existing algorithm. You will do minor modification. Again, minor modification in the flowchart. Again, testing will be done, all the things. If all are perfect, then go to analysis. Analysis also okay, then lastly go to coding. But remember, as a computer science student, as a DA student, your responsibility is, right, designing algorithm, right, analyzing algorithm, how. That is the purpose of this subject. Now first let's talk about analysis. Right? What is the purpose of analysis? Analysis purpose is to decide which algorithm better. How you decide? Based on the time complexity, space complexity. Next question, how you find out time complexity? So time complexity of any program is equal to compile time plus running time. Compile time is nothing but, compiler is a software. Compile time is based on compiler written in which language. Compiler is written in the slow language, compile time more. Compiler is written in the faster language, compile time is less. Right? Running time is based on the processor. Right? If the processor is slow processor, running time is more. If the processor is a faster person, right, running time is less. So compile time is based, right, totally time complexity based on these two people. Next one. If time complexity based on these two people, if you analyze the algorithm based on these two people, that is called as post-theory analysis. Time complexity based on the actual people, that is called post-theory analysis. Time complexity independent of these two people, that is the priori analysis. Because of independent, you will get the approximate answer. Because of dependent, you will get the exact answer. Right? So the problem with the exact answer is computer changes, time complexity will change. Slow computer, more time. Faster computer, less time. So the advantage with the independent analysis is it is based on, right, it will give same answer in every computer. Every model having its own story. Every model having its own story. Priori analysis, post-theory analysis. Name itself saying post-theory means postponing. Post-theory analysis means postponing. Postponing means, right, I think keeping the delay. I asked what is the time complexity. It is saying that I am based on something. If you say those, then only I can give answer. Means it is in the waiting state. But priori analysis means saying immediately. Independent analysis. Remember like that. Post-theory means waiting. Why I am waiting? I should know language of compiler. I should know type of processor. Oh, that is the reason you are waiting. So post-theory means postponing. So priori analysis means immediately. Why? Independent. Actual things I don't want. So approximate answer. Right? And in every computer, same time complexity. Okay, I think you got it. Now, can anyone help? Can anyone help? Total software industry follows which analysis? Can anyone help? Total software industry follows which analysis? You will get to know. You will get to know. You will get to know. Within few minutes, numericals will start. Within few minutes, numericals will start. That is the theory. As directly, I cannot go to the numerical. It will trouble you. Directly, I cannot go to the numerical. It will trouble you. Directly, I cannot go to the numerical. It will trouble you. Can you help me? Total software industry follows which analysis? Total software industry follows which analysis? Hello? Total software industry follows which analysis? Post-theory or priori? Can anyone guess? Total software industry follows which analysis? Priori or post-theory? Everyone try to give answer. Total software industry follows which analysis? Priori or post-theory? Everyone. Priori or post-theory? So remember everyone. Right? That is the reason in the software companies, right? There is a employee, right? See this one, employee of the month, developer of the month, best developer of the month, best developer. Remember, I cannot decide best developer based on the which processor he is using. He is using Mac, he is the best developer. He is using Lenovo, he is the worst developer. He is using Dell, he is the worst developer. I cannot say like that. I cannot decide a particular developer is what. But if he using Mac, he is a very good developer. He is using the Lenovo, he is the worst developer. He is using the Dell, he is the best developer. I cannot say. Remember everyone, your ability based on the logics. Remember, priori analysis is independent of processor speed. Priori analysis is independent of programming language. Priori analysis is, right, based on the logic. If you write the best logic, time complexity less. If you write the best logic, remember priori analysis, concentration, logics only. Posterior analysis, concentration, best computer. Posterior analysis, right? Target is best computer. Best compiler, best computer. Best compiler, best computer cannot give best algorithm. Right? Best algorithm decided by logic only. Can I help you now? In these two techniques, which is based on the logic? In these two techniques, which is based on the logic? First one or second one? First one is saying that supercomputer, then only algorithm faster. Second one is saying that supercomputer doesn't matter. Logic matter. Total software industry follows priori analysis. Total software industry follows priori analysis. Total software industry, not suppose if you start the software company, right? There also you will follow priori analysis. Right? Remember, if you have a Mac, maybe little bit faster, it's okay, but logic will decide. There are, see, many people are having the Mac in front of them. They don't know the right algorithms. They don't know DA. They don't know DSA. They cannot write the good programs. There are some people who are very poor. There are some people very poor. They don't have good computer. They have very bad computer, but they are so good in the coding. So what I mean to say is, posterior analysis saying that supercomputer is there, then only program faster. But some people, right, priori analysis saying that if you use the brain super way, if you have a super brain, then also your program faster. Remember, priori analysis saying that brain is the reason. Posterior analysis saying that Mac is the reason. Posterior saying that Mac is the reason why my program faster. Priori analysis saying that, right, my brain is the reason why program running faster. So total software industry follows priori analysis. Right? So I am just writing one important point. Please take care. Everyone listen. Note. This is a very, very important point. From this is the conclusion. Everyone may not have supercomputer. May not have supercomputer. Everyone may not having supercomputer. May not have supercomputer, but everyone have super brain. Everyone may not be rich. Everyone, supercomputer means if you have more money, you can buy supercomputer. Everyone may not have supercomputer, but everyone having super brain. If you use properly, you can write super algorithm. Some students are crying. My parents are poor. Means you may not buy supercomputer, but your parents may be poor, but your brain is so rich. Your brain is so rich. So using that brain, write the super algorithm. Over. Right? Everyone may not having supercomputer, but everyone having super brain. So the reason is, right, God is given to all. God gave super brain to all, whether you agree or not. God gave super brain to all. How you use that matters. If you use that brain for some other purpose, your brain may not work. So I'm repeating once again. Everyone may not have supercomputer, but everyone having super brain, because God given super brain to all. Some people are using, some people not using. God gave super brain to all. Some using, some not using. What can I do? Some using, some not using. But one thing is true, God is given same brain to all the people. Super brain, God is given super brain to all the people. Some are using, some are not using. God never show partiality. God is not a human being. God is not a human being to show partiality. My friend having very good brain, I don't have. No, bhaiya. God is given same brain to all. God gave super brain to all the people. Some are using, some are not using. This is the only difference. So everyone may not have supercomputer, but everyone having super brain. Using super brain, you can write super algorithm. That's what the priori analysis is saying. That's what the priori analysis is saying. That's what the priori analysis. God gave super brain to all, some using, some not using. If you are not using, it is your problem. Don't blame the God. If you are not using your brain properly, it is your problem. My mama is poor. My papa is very poor. So we are very poor. You may not be rich. By money, you may not be rich, right? By brain, you are so rich. That is the reason where are you studying? That is the reason you are studying. Otherwise, you could have done farming. Otherwise, you went to the daily coolie. Otherwise, you became a right. I think some work doing some farming work. What I mean to say is, you may not be rich by money, but you are rich by brain. So please start use at least from now onwards. Don't blame my papa is poor, my mama is poor, my village is poor, I am poor. Don't say that. That is you may be poor. That's okay. But by brain you are so rich. That is the reason you are studying BTech. That is the reason you are studying. Where are you now? So everyone may not buy supercomputer, but everyone can write super algorithm because God is given super brain to all. Some are using, some are not using. So remember priori analysis saying that using your super brain, you can write super algorithm. Right? So priori analysis. Write down topic name, priori analysis. Topic name you can write priori analysis. Priori or priori, whatever it is. Priori analysis. So trust me, everyone. This is the place where problems will start. This is the place where problems will start. Tomorrow, as soon as I will start from here. There are 30 problems are there. Tomorrow, as soon as I will start from here. There are 30 problems. This is the starting of algorithm subject. To be frank, algorithm subject will start from here. To be frank, algorithm subject will start from here. Tomorrow, this time you feel so happy. Tomorrow, this time you feel so happy. You feel that algorithm subject you are getting. Till now, only theoretical things are there. Without saying all these things, I cannot go. I cannot go to numerical problems directly. I cannot say numerical problems directly. Right? All the theory I have to say clearly. What are the definition? What are the properties? How to design the good algorithm. Right? Next one. What is the analysis? Next one. Based on the what factor analysis is designed, how many types of analysis there. So finding time complexity, space complexity, which analysis you are following, priori analysis. Tomorrow, as soon as I will start from here. Sharp 6 o'clock, I will start. Sharp 6 o'clock, I will start. Make the nice notes. Make your own notes. Make your own notes. Make your own notes. I think today is, listen, today is approximately 6th. At the end of this month, algorithm will be over. Today is 6th. At the end of this month, algorithm will be over. Please plan properly. If you learn properly algorithm now itself, if you learn algorithm properly, right? I think I'm saying to you, you are going to crack many companies. You are going to crack very good gate rank. You are going to crack, right, very good company. Yeah. So can we stop? Can we stop? No, it is not stuck. So I thought class is anyhow over. So I thought of not keeping charging, but unfortunately charging over before all. So it's not stuck. I think charging problem. I thought charging is enough. I thought charging is enough. Fine. Can we stop? Can we stop now? Tomorrow, as soon as we start, I'm going to cover 30 problems. I'm going to cover 30 problems. Right? Tomorrow, as soon as I will start, I'm going to cover 30 problems. So please careful. Right? Yeah. Bye then. Bye. I'm stopping. Right? Thank you. Thank you so much. Thanks, everyone. Thank you. Please revise all of them one time. Please revise all of them one time. Okay? While coming to the class tomorrow, please revise all of them one time. Yeah. Thanks. Thanks, everyone. Thank you. Bye. Bye, everyone. Bye.